Okay, Year 11, I'm going to go through some of these curve sketching because I'm pretty sure you had a bit of a hard time with them. So I'm going to do a couple of the earlier ones because I still reckon you had some trouble with it. I'm going to start with this one here, and then I'm going to do some of the other ones. So what we need to know is that when we're graphing these, it's y equals k, and I'm using the terminology that you're going to see in year 12, sine a x plus, can't remember whether it's c or b. Let's go back, we'll check on the website. And you can see here, it's B, and then there's A, there's a B, then a C. So we'll go back here, AX plus B plus C. And remember what these things do. That affects your amplitude. That affects, I'm going to use the terminology again, the period, tells you how many curves you're going to have. And the period here is, because the normal curve is 2 pi, it's 2 pi over whatever that number is there. This affects your phase, which is just a shift left and right, horizontally. And Margaret calls this the center, but it just shifts it vertically. Now, if you get all that, and that's hard, you should be okay. So let's start with this one. Y equals 2 sine a half x. Oh, so you can take the half out? Yeah, you can take this. You know, x over 2 is the same as a half x. So what is this? Well, it's 2 sine x, right? So it's 2 sine x, and there's a graph of sine x, but we only get half a graph. So first of all, we know it goes from 2 to minus 2 because the amplitude has changed, but we only get half a graph. So we only get it from there, 2 pi. This bit doesn't exist, or it's not part of the curve that they want. They only go from 0 to 2 pi. So, and I'm just getting the answers in front of me so I can double check. So this is question 3I, which is what it is. So they're pretty easy. So here, this would be 3 curves if you did C. So if you're doing C, y equals sine 3x. Well, you just go along here and you draw 3 sine curves. 1, 2, 3. And you say, oh, okay. And that would now be 2 pi. So 1.5 curves would be pi, because halfway. And then halfway between those ones would be pi and 2. And halfway between these ones would be 3 pi and 2. And because it has no number there, there's a 1 there, which means its amplitude is 1 and minus 1. So they're pretty easy, those standard ones, when you're just playing with the amplitude and the period. But when we start playing with the shift, so I'm going to take D I might take E and F, and I might just take A, so you know what we're doing. So A, y equals sine x plus pi. Well, I'm just going to dot the sine curve. There it is. But we've shifted this horizontally. We've moved it horizontally. Now, how do you know what you've moved it? Well, you've got to put whatever is inside there equal to 0. What's going to make that equal 0? And for that to equal 0, x has to equal minus pi. So this is moved to the left, pi. So if I just go in here, and I go, oh, pi's there, and that's pi. If I've moved it that far, that means it'll be going here, and then it starts. Yeah? So you shifted it back to the left. You shifted the typical sine curve. You moved you can actually, some people like to say you've moved the y-axis back to there. And that's where the curve would have started. And by the way, that's minus pi, sorry. So that's a nice easy shift. Now, what about E? F of x is f of x equals 2 cos x plus pi on 2. All right. So let's double check. Is that the right one? Righto. So what you've got to do, now it's going to go up and down to 2. That's all right. I can put the scale in any time I want. But I'm going to shift it to minus pi on 2. So this is where it would normally start. So minus pi on 2. And cos curve, the cos curve starts up here. So, and once it hits that, I'm starting the curve. So down, up, down, and let's finish it here. We've got to get a whole curve. We've got to get a whole curve, and the whole curve is actually there. There's one whole curve. So that's going to be my 2 pi. That's going to be my pi. That's going to be my pi on 2. That's going to be my 3 pi on 2. It's a negative cos curve. Oh, and it's going up and down 2 to minus 2. And what was that one? That was E. And I'm just checking for E. There it is. Oh, but they wanted it from, am I looking at the right one? Oh, 6E. I was looking at 4E. And yeah, there it is. And remember, you can always check it on Desmos, which is always a good thing to do. And it helps you see the shift as well. So what was it? Y equals 2 cos x. So we'll type in y equals 2 cos x. And there it is. We'll dot that. Because that's not the curve we're looking for. What we're looking for, now watch this. Y equals 2 cos bracket x plus, now it's pi. I know you can get pi somewhere. I'm just going to use 3.14 divided by 2. And there you can see it just shifts it back. Shifts it back. Pi on 2, 90 degrees. And you can see the part that we want. Okay, so let's go to F, because F was a hard one, and it's the only one that was a bit dodge. 4 sine 2x plus pi on 2. Y equals 4 sine 2x plus pi on 2. Now the critical bit here, with all the others, this 2 has been out the front of the brackets. Once we put it inside the brackets, it makes a huge difference. Now, you're going to think that, this shifts this negative pi on 2, but that would be a mistake, and that's a mistake I made in class. We've got to find the inside of the brackets that makes it equal 0. So let's do that. 2x plus pi on 2 has got to equal 0. So 2x equals negative pi on 2. Divide by the 2. It shifts pi on 4. It shifts 45 degrees. And we're still going to get 2 sine curves. That's going to give us 2 sine curves, and it's going to go up and down to 4. So let's draw it. And we've moved it pi on 4. Okay? So normally it would start here, and pi on 4, that's it, that's pi on 2. Pi on 4 is here. Right? So we've taken it, and that's my pi on 4. So I'm just looking at this in the textbook. What is it? 6F. It's got it all the way at 1, which means it should be at 90. It should be at 90. 2x minus pi on 4. And it's going... Oh no, because there's 2 of them. Because there's 2 of them. Because there are 2 curves. That's what you've got to remember. All right. Because it's 2 of them. That's why this one is really hard. This is what it would be normally. You get 2 of them. And that's your pi on 2. And that's your pi on 4. All right. So, because there's 2 of them. So we're shifting it, because that's what the 2x does, and it goes up and down, up and down to 4 and minus 4, and we shifted it pi on 4, so we've shifted it back to here. So the real curve is just that part, and we've got to move it back. So it's going to look like 1, 2. And that was a very difficult one. 2 pi, pi on 2, 3 pi on 2, 4 minus 4. Right, and so you could see that I got caught up in it as well, because I forgot about having 2 curves in there. So there's 2 curves. But it didn't shift pi on 2, it shifted pi on 4, because all of that's got to equal 0. So that was, that was quite difficult. Yes, if you got that one, good on you. Now, let's go to adding some ordinates. Righto, because these are hard. These are hard. So I'll do 10, and I'll let you have a go at 11 and 12, and then you have a go at 13. And I'll do 13 as well. 13 is a really cool one. So what do we got? Sine x and sine 2x. So I'm going to graph y equals sine x and y equals sine 2x. And then I'm going to graph f of x equals sine x plus sine 2x. Okay, and we've got to do them on the same sketch. So I'm going to draw a pretty big one. And I'm going to use a bit of colour, and I'm going to dot. So here's sine x, Now sine 2x gives me 2. So I'm going to dot it, and I get 2 of these. So I get 2 of them in there. And it probably needs to be a bit better. Righto. And they both go up to 1. So there's 1. And there's -1. Now you can think, oh, I'm going to add the ordinates. And I'll do it in green. What I want to do is I want to add the y values of that. So here both y values are 0, so that's nice and easy. Here, this y value is 0, so it's just going to be that y value, and that's pi on 2. All right? Here, they're both 0, so it's going through there. Here, they're both 0, so it's going through there. Here, this is 0. Oh, okay, so it's going to be there. That should be right up the top of it. Well, that should be the apex of it. That's going to be 1. Now, you can think about this and go, oh, here, somewhere around here, and I'll go back and use this. I don't want to use blue. I'll use yellow. In these spots, those two we're going to add up to a bit more, so they'll end up about here. I'm just guessing. They won't go more than 2 though, because the max it can be is going to be less than 2, because there's no times when they're both at 1 and 1, I'm doubling it. For these values in here, these values, if I add them together, I'm adding a positive and a negative. Now originally the positive ones, you know, the positive ones are higher because they're linking up with these ones, but eventually these ones get bigger. So eventually it's going to come below. So it'll go down here, it'll cross somewhere, and it'll go back. So it's going to come down like that. Again, the same thing's going to happen here. The same thing's going to happen here. It's going to go across below, and it's going to come down again, and then go up here. And then here, with these 2 bits, I'm going to end up somewhere up there. All right? So my curve will look something like that. Now you don't have to do it by guess. You don't have to guess it. What you can do is you can do yourself a little table. So you can go, all right, I'm going to pick some values for x. I'm going to find some values for sine x. I'm going to find some values for sine 2x. And I'm going to find some values for sine x plus sine 2x. And you just draw yourself a little table. And you put your critical points in. So you're going to obviously grab x equals 0. You grab, I don't know, pi on 3, because that's a nice easy one. You might grab pi on 4, pi on 2, pi, 2 pi on 3, 3 pi on 4, two pi. I'm missing a few, but that's okay. Remember, this is, that was silly of me to do that one first. Should change this one, make it pi on 6. And I should have done pi on 3 as well, but that's okay. So that gives me 30, if you like to think in angles, 45, 90. And I'm going to get rid of that one. I'm going to make that 5 pi and 6. No, 7 pi and 6. Yep, 7 pi. So I want to go. I want another one in there. So I'm going to have 90 plus 30 is 120. So 2 pi on 3, because pi on 3 is 60. So 2 pi on 3, which gives me 120. And then I'll go pi, which is 180. Oh, sorry, silly, should have gone 3 pi on 4, which is 345, so 135. And then my pi. And you can just do lots of these, so that gives me 180. And I might get rid of this one. Let's go 210. Now 210 is 730, so 7 pi on 6. Let's go 225. And that's 545s. 5 pi on 4. And then we'll go 270. 3 pi on 2. And then we'll go 300. 300 is 10 30s, so 10 pi on 6. Which is the same as 5 pi on 3. We'll go 315. So that's 145 less than 2 pi, so 2 pi, which is 8 pi on 4, so 7 pi on 4. And we'll go 360, which is 2 pi. Now you can put them into your calculator, which is what I'm going to do now. I'm just going to add them. 0, 0, 0. Oh, now, because I've chosen these ones, I actually don't need a calculator. So I can go, here's my pi on 3. Here's my pi on 6. 1, 2, root 3. You can see why this is a lot harder. And I go my pi on 4. 1, 1, root 2. So here we go. So sine pi on 6, that's a half. Well, sine 2 pi on 6, well, that's sine 60, because I'm multiplying that. And sine 60 is root 3 on 2. So if I add those together and I use my calculator, so 0.5 plus root 3 divided by 2 is 1.36. 1.37 really. Now if I do 45, that's 1 on root 2. And that becomes sine 90. Now sine 90 is 0. Yeah? Sine 90, oh no, it's not. Sine 90 is 1. Yep. So 1, and 1 plus 1 on root 2. 1.707. So you see it gets pretty close to 2, but it doesn't. Well, we know sine 90 is 1. Now that's sine 180 because 2 90s. Well, sine 180, we can see it here, is negative 1. So that equals 0. All right, because sine 180, So sine 180 is 0, you idiot. Should check on my calculator. And when I add them together, I get 1. And what you do is you create a table of values. And this is what you're plotting here, these ones. So you get 0, and then you know your critical ones. So you're going to get here, you're going to get sine 180, and that's 0. And you double that, sine 360, and that's 0. So there's your 0, 0 at the end, yeah? Or one of your zeros. And when you get over here, sine 360 is 0, and you double that, sine 720 is 0, 0, 0. And you get these points and you plot them all along, and you'll find that they'll be the same values, but they'll be negative. So when you get sine 120 here, sine 120, well, that's the same as sine 180 minus 30, and they're all positive, so it's just going to be the same as the 30s over there. So a half, root 3 on 2, and 1.37. Sine 135, well, that's negative, all right? That's going to be negative there. Oh, hold on. Have to be careful here. That's going to be, because that's double that's going to be 240. Sine's going to be negative. It's going to be the same value, but it's going to be negative root 3 on 2, which gives you 0.5 plus root 3 on 2 negative negative 0.37. And then the same is going to happen here. You're going to have double negatives, like, because they're negative, all stations 2, yeah, that'll be 270. So that's going to be negative 1 on root 2 for sine 135, and double that's 270, and sine 270 is negative 1. So negative 1.707. And this is going to repeat. And then you just plot the points the same way as you go through. But it's better if you can think about adding ordinates. So what I'm going to do now is I'm going to do number 10. You should go and have a crack at that, at doing 11 and 12. And I'm going to do 13. So you come back and when you've had a go at 13, which is y equals sine x, y equals cos x. But what we want to graph is f of x equals sine x plus cos x. So what you want to do is you want to graph them and do them dotted. So here's sine x, and here's cos x, and what you do is you get the points where there are zeros, because they're really easy to plot. So here, this is 0 and this is 1, and if I add them together, I'm going to get that. Now, here, this will be 0 here, and that's 1, so I'm going to plot that. So there we go. Now, here, this is going to be 0 and negative 1. I haven't really drawn it well to scale. Here, this is going to be 0 and negative 1, so it's going to be there. And here, it's going to be there. Now, here and here, if I add these two together, it's going to end up here. And here and here, if I add these two together, I'm going to end up down here. So my curve is going to look something like that. And that's question 13. And let's have a look at it on Desmos. That's the best way to check it out because you can see it much better. So again, draw y equals sine x and y equals cos x. And y equals sine x plus cos x. And if we dot these ones, come on, let me dot you. Let's go back there. Righto. And we go in here and dot that one. And you can see we get exactly what we did. And you can see they've indicated the critical points here. 0, 1, when it's pi on 4 and 707, 0 and this one here, which are all the points that we pointed out. And that's a better way to try and sketch it by adding ordinates. Now remember, you can go and pick points and plot them and get them if you want to. Good luck with those.